So great to be here. We're going to talk about service mesh to service mesh. You can grab these slides on robrich.org. Let's head there right now. robrich.org, click on presentations, and you see service mesh to service mesh is right here. Here's that link. You've got the slides online right now. While you're here, click on About Me, and you'll get to this slide and talk to some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp is really great. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. Here's some of the other things that I've done. One of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So here's my coveted .NET Rocks mug. Service mesh to service mesh. Oh, no, that one. Here. So we talked about this guy. Do you remember when you learned to drive? Do you remember how fun it was to be able to hit that open road, to be able to experience a whole new frame of reference? No longer were you limited to how far your bike could go. You remember that, how cool it was to drive fast? Well, let's imagine this country road where we can all drive really fast. Well, in time, we might lead to something like this, where we're all just trying to get there as fast as we can, and we're all in each other's way. This country road is starting to get kind of busy now. Well, so how do we defend this? How do we get all of us to where we need to go as efficiently and as systematically as we can? So let's put a traffic cop right there at the edge of town. And he's going to go look at everyone coming into town, and he's going to say, are you going too fast? And if so, then he'll give you a ticket, and he'll make you slow down. Well, we've gotten everyone through the traffic jams, and we have now a mechanism for finding things that aren't compliant, but we haven't really worked on getting people there efficiently. Instead, we've focused on conformity. Everyone go the same speed. And traffic really doesn't work that way. Traffic isn't prioritized based on how fast you're going. Traffic is prioritized on what is the urgency of your trip. So really, we want to focus on something like this, where the cars can start to communicate with each other. Now we can prioritize traffic based on urgency. Let's let emergency vehicles go really fast, in spite of the fact that the rest of the traffic may not. Let's let people who urgently need to move through urgently, and those who want to move slower definitely can. As we prioritize traffic, now we can start to optimize for getting there as fast as possible, as opposed to just optimizing for conformity. We'll use this metaphor as we start talking about service mesh, because this type of metaphor is inherent in the way that we do service mesh. Here's some of the things that we're going to talk about. What's going to be really cool is live demos here of both Istio and Linkerd. That will be really cool. So a service mesh. A service mesh is that mechanism, that gateway between traffic in our cluster. Now, it isn't just the traffic cop on the edge of town, but it proxies traffic between all of our services. It's the answer to how do I observe, control, or secure communication between microservices. If you have that need to control, observe, or secure communication, service mesh is perfect. Observe. First thing we want to do is we want to be able to see all of the traffic moving in our cluster. Once we're able to see that, now we can create access policies that start to restrict that traffic based on necessity or based on security rules. And then secure that, we can create mutual TLS between our containers, and we can do this without the need to implement this in each container. A service mesh is able to accomplish this. How did we get here? Well, we started out with this mechanism here on the left, a monolith, and we moved to this mechanism here on the right, microservices. We chose monoliths back in the day because deployment was really hard. We would put off the inevitable and do it once in as much as we could. We would go through these processes of, get on the call Friday after work, and hopefully by Sunday afternoon, we've kind of worked out all the bugs. What was wonderful about this monolith was all of the pieces were deployed together. The downside is it was still really painful. As containers came online, we got to move here to the mechanism on the right where we have microservices. Each microservice now can communicate with other microservices, and those microservices are easily scaled up or replaced to accomplish the task that we need within our cluster. As we talk about traffic here in our cluster, we'll talk about two different types of traffic. We'll talk about north-south traffic and east-west traffic. When we think about north-south traffic, that's traffic flowing into our cluster and traffic flowing out of our cluster, as opposed to east-west traffic, where we talk about traffic going between containers. Switching back to this diagram, as we look to the microservices, north-south traffic is that traffic moving in and out of the cluster. East-west traffic is microservices calling each other. The cool part is that a service mesh can secure both types of traffic. So we can validate traffic coming into our cluster, we can validate traffic leaving our cluster, and we can also validate traffic between our containers. So we got to this mechanism where we have this challenge. We need that traffic cop at the front of town. And so we put here our barrier, an API gateway. Now, an API gateway is great at being able to validate that nobody's speeding into town. But an API gateway is only that fence around the cluster. It can do nothing about communication between components within our cluster. Now, in this case, we have microservices correctly calling each other, but we also have microservices reaching into each other's data stores. We don't want that. The unfortunate part is that the API gateway can't validate this at all. The API gateway is this fence at the edge of the cluster. So we need to upgrade. And so API gateway was great, but let's upgrade to service mesh. Here's the methodology of a service mesh. Now, service A wants to reach out to service B. In this case, when we have a service mesh in place, service A doesn't directly communicate with service B. Rather, service A reaches out to service A's proxy, this sidecar container running within the same pod, and this proxy will then reach out to the service mesh control plane. Am I allowed to talk to service B? In this case, the control plane is going to say yes, and so this proxy reaches out to service B's proxy. Now, this proxy again checks in with the service mesh and says, am I allowed to accept requests from service A? In this case, the service mesh says yes, and the request is forwarded off to service B. Service B replies, and it flows back to service A. Here's that mechanism of how service meshes get this process done. Service A will reach out to its proxy. The proxy checks in with the control plane. The proxy then reaches to the other proxy, and that proxy checks in with the control plane as well, forwarding the request, only if allowed, to the service. The cool part about this is now we're standing in between the communication between all services. So we can do some really interesting things like observe, control, and secure. For example, this can be a mutual TLS connection where we don't have to change the content between our service and the proxy. This all lives inside the boundary, the network boundary of a pod, and that communication between the services is secured with mutual TLS based on a trust chain through the control plane. So observe, control, secure. As we're doing this, we can observe all of the network traffic flowing through our cluster, not just inbound traffic, but intercommunication between containers. Now we can start to create policies that will restrict that content based on various rules. Maybe let's not allow services to reach into each other's data stores. And we can secure it with mutual TLS if we opt into that mechanism. So a service mesh is not just that proxy, but we can start to layer concepts on top of this. We can create a network topology diagram. Now, the interesting thing here is it's not just what the developer thought would happen, but what's actually happening in the cluster, which is perfect. Service health. We can see when services are misbehaving, and we can take corrective action. Like in this case, we'll log them to a log, so we can get a feel for how our services typically behave. Leveling up again, we can create things like A/B tests, where some of the traffic will go to one cluster, one container, and some of the traffic will go to another container, and we can evaluate which one works best. Or perhaps we have a beta channel where certain users can opt into new functionality. Or maybe we have a circuit breaker. One of the things that is really typical of containers is when a container starts to fall over, all of the things that depend on that container getting a failure request, of course, are just going to retry. So now we have this flood of retries for this service that is already overloaded. And so it starts to waffle up and down. Instead, let's trip a circuit breaker and let's get permanent failures to all the services calling right now. As the service starts to come back online, we'll open that circuit breaker back up, and now we can get traffic flowing smoothly. We don't get that up and down mechanism. So inherent in a service mesh, we'll also get dashboards. On the left, we have a Grafana dashboard showing Prometheus data. On the right, we have a network topology diagram. And each of these dashboards is able to do really interesting things. So, for example, we can prevent unexpected traffic. No longer are these services calling each other, but rather we can create those policies that will ensure that microservices call other microservices, not each other's data store. As we look at various service meshes, we have Istio, Linkerd, Console, Open Service Mesh. Each service mesh has its features and benefits and costs. And the hard part is the moment that I tell you any of those is the moment that it changes. So instead, let's pick two examples. We'll look at Istio and Linkerd, and we'll look at the methodologies involved, not necessarily the implementation. So for example, Linkerd focuses on being self-contained. They write all the pieces themselves, and they focus on those core functions that you need to be able to accomplish the task at hand. They don't do a whole lot of ceremony and optional features. If you need those optional features, you'll need to go to external plugins. By comparison, Istio is that kitchen sink. It has all the things included, and you can turn it on and off based on profiles or based on allowing or removing features. So Istio has a lot of external tools bundled in with it, and those external tools are the best of breed for those particular technologies. By comparison, Linkerd likes to build everything themselves. So using those methodologies, you can kind of pick between, do I want a simpler approach with Linkerd, or do I want kind of everything that I'll ever need with Istio? And you can research the other methodologies in other tools as well. Let's take a look at each. Istio and Linkerd. Let's use Linkerd context. And now we'll take a look at some of the pieces of Linkerd. Linkerd is really proud of their getting started experience. It is really, really fast. So I've already got the Linkerd CLI installed. And let's fire up our cluster. First step is to check the cluster. So Linkerd check -- pre. It will start to do all those checks to validate that my cluster is okay. By putting in the -- pre, I'm not validating that the content is installed, only validating that I can. Next up, let's start to apply it. Linkerd install, pipe it to kubectl, apply -f, and now we'll get all of our Linkerd content put into place. Now it's doing a lot. It's installing the Linkerd control plane. It's installing all of the pieces it needs to be able to do mutual TLS. It's installing all of the monitoring containers. All of the content that we need to get Linkerd in place is installed. So it still has that control plane. And then it has all of the pods that we'll put in, the sidecar proxies that we'll put into place. So as Linkerd gets installed, looks like it's taking a minute. As Linkerd gets installed, we'll be able to then come back through and check it. So Linkerd is installed, and now let's do a Linkerd check. And Linkerd check will not only validate that all the Linkerd pieces are installed, but also that they're running. So this will take a little bit while it fires up all of the Linkerd pieces, and that's totally fine. But that's how easy it was to get Linkerd installed. Once Linkerd is installed, we can take a look at some of the dashboards and tools that Linkerd provides. Wow, that's really taking its time. So the Linkerd controller is initializing. Let's set Linkerd aside because, oh, there it goes. Linkerd is really cool to get installed. It is that easy. Switching over to Istio, let's take a look at how Istio is built. Istio, the getting started instructions are really cool as well. I've already downloaded the Istio control plane, or the Istio command line interface, and downloaded the sample app. So with this sample app, it is built like this. We have a product page, and it will reach out to get the product details. And then we also have 3 different versions of product reviews. Some of them will show no stars, some of them will show stars in black color, and some of them will show stars in red color. So right now it's set up to hit all 3 services. As we refresh this page, we'll see that randomly we'll get different numbers of stars here in our demo. It looks like we're getting version 3. There's version 2. And if we refresh it again, there's version 1. So now let's get a little bit more control over this. We want to take a look at kubectl apply -f. What is it? Virtual service reviews. So we're on the V1. There we go. So we were on this one that gave us all 3. And let's flip over to the one that will give us only version 1. Now when we hit refresh, now we only have the one without the stars. Well, let's test it out. Let's go to version 2. Now this one will send 80% of the traffic to version 1 and 20% of the traffic to version 2. Let's grab this control plane, rename, kubectl apply -f virtual service 8020. Now without our service going down, we now can do this A/B test. Let's get some content going, and about 20% of the time we'll start to experience version 2. In this case, oh, there we go. There's version 2. No downtime in our application at all. That worked out really well. Once we decide we're good, we can flip over to exclusively version 2. Or we can do some things like this, where here we want to go check out version 3. So for the user JSON, we'll hand them version 3. And for all the rest of the users, we'll hand them version 2. Once we're good there, we can maybe go 50-50 with version 2 and version 3. And then once we're good, we'll flip over completely to version 3. There's no downtime as we do this, because this is all just virtual network switching. And so once we're flipped over to version 3, then now we're exclusively on version 3. And so now when we refresh our page, we only get the red colored stars. Istio made this possible because it was able to virtually route traffic based on these rules. Now we do have a lot of dashboards involved. We didn't get a chance to see the Linkerd dashboard, so let's pull up some. Let's pull up one of the dashboards here in Istio. We'll pull up the Grafana dashboard. Both Istio and Linkerd have Grafana dashboards. The cool part about Istio's dashboards is that it's already got some content in place, and so we can take a look at these dashboards. Let's go to Home, Istio Service Dashboard. And here's a dashboard. Granted, this cluster has been up for, I don't know, about now. So there isn't a whole lot of history here. But we get to see the details of this particular thing. Let's take a look at the Kiali dashboard. There we go. And the Kiali dashboard, I believe, is the one that will map the network. Ooh. So now I want to go to the Graph tab. Yes, here's our network diagram. Now, what it's doing is it's noticing how the traffic moves in our cluster. This isn't the network diagram that the developers built. This is the network diagram that the service mesh was able to infer from our cluster. That's perfect. So we got to see both Istio and Linkerd. Istio focusing on being the kitchen sink of all things, and Linkerd focusing on that really fast user install experience. As we look at service meshes, we can start out with that first level of monitoring, logging, and service health. That's kind of the crawl stage here. Let's level up and talk about intelligent routing, where we now can create mechanisms for doing this type of A/B testing or circuit breaking. And then ultimately, the master plan here is that we get that network topology diagram that tells us what's actually happening in our cluster, not just what we thought was going to happen. At that point, we can take a look at it and say, oh, did we forget and leave that debug statement in place? Zach Butcher wrote a book about Istio and says, if it doesn't have a control plane, it ain't a service mesh. That control plane is the thing that will issue those certificates so that we can do mutual TLS between containers. And the control plane is the thing that makes those decisions based on those routing rules. So do I get this for free? Well, no. On the left, we have all the normal components in our cluster. On the right, we have all the pieces for our service mesh. On the left, we have our control plane. Kubernetes has the etcd database and the API server and all those pieces. We also have all of the content in each worker nodes. We have the kubelet and the cAdvisor and the kube proxy. And then finally, we have our pods that do our work. When we add a service mesh, we have the control plane associated with the service mesh, the part that does the certificates, the part that does the routing, the part that does the validation. And then we also have our pods that do reverse proxies. So probably when we add a service mesh to our system, we'll end up with twice as many containers in our cluster. Now that's a non-trivial amount of hardware. Granted, the proxies are probably doing less work than our actual services. If we're using a Java service that has lots of RAM involved, then we may end up with not twice the compute horsepower, but it's probably not unexpected to say that we'll have maybe 1.5 times. We shouldn't just choose a service mesh because it's the thing. We should choose a service mesh because we need to observe, control, and secure the content in our cluster between containers. If we have these needs, service mesh is perfect. Here's my rules of thumb. If you need really trusted workloads like PKI, PCI, running untrusted workloads together with your regular content, or you're running a multi-tenant cluster, then a service mesh is perfect. If you need security in depth, or you need some of that advanced routing, then a service mesh can definitely help. But because it's a non-trivial amount of horsepower, you probably don't need a service mesh if you're running all first-party workloads. If you're running in a multi-tenant environment, Kubernetes namespaces are not security boundaries. They are organizational boundaries, and you definitely want a service mesh in a multi-tenant environment. This has been a lot of fun walking you through both Istio and Linkerd. What are your questions?
All right, thanks, Rob. Let's kick off the Q&A with a few questions. Okay, so the first one I wanted to ask was, say I'm a smaller company or a startup, and I don't have a very large infrastructure footprint. Does a service mesh still make sense?
I would say in that case, probably not. We haven't tripped any of the best practices here. We don't have really high security workloads. We don't have untrusted workloads. We only have first-party workloads. And so it's probably not worth the cost of the additional hardware.
Okay, great. I wanted to also probe a little bit about other types of services. So say instead of just having RESTful APIs or stateless applications, you have some event processing. Can they still fit into this service mesh world, or are they outliers?
Most definitely. The event workloads can definitely fit into a service mesh workload. In that case, when I have event processing, I'll probably put a service mesh in a service mesh client-side proxy into each of the pods associated with that enterprise service bus. Perhaps I'm using Kafka, and so I'll put the proxy in with each Kafka node. And then I'll also put the proxy in with each web service or even some of the data processing services. So as they reach out to Kafka, I now have secure communication between my service and Kafka. And that's really ideal if I need to validate content between all the entities in my cluster. If I'm doing some other workloads, maybe I'm doing GraphQL and not just REST, then I can definitely secure that traffic as well. It isn't necessarily limited to layer 7. I could route at layer 4 if I need to, and certain service meshes are able to go even lower in the OSI model as well.
Awesome. Okay, here's another question. So we talked a little bit about this, but can you give some examples of how using a service mesh actually increases your observability?
Yeah, definitely. We looked at the Kiali console where we got to see the actual topology of our system. Here's the diagram showing what the developer thought was going to happen. We have the product page, the product details, and these 3 review services, of which reviews 2 and reviews 3 reach out to this rating service. But with this Kiali console, we can see how that actually happened. Here's the traffic that flowed between all the things, and we can see them actually making those connections. If we wanted to, for example, add some debugging content here into version 2 to not reach out to ratings, but rather to hard code specific values because we're debugging it, then we would see in this diagram that that connection wasn't there. That would be a great signal for us that maybe this service isn't up to snuff. Let's not cut over. We also looked at Prometheus dashboards here, where all of the Prometheus events flowing out of our cluster flow into this dashboard, which is currently offline. And so this gives us a whole lot more insight into our cluster as well, because we get to see the events happening in our cluster. We can see things like service uptime and failure rates. And is this service misbehaving more or less than expected? Maybe a service is failing quite a bit, and I should kick that container and restart it. Or perhaps there's additional latency or memory requirements that I didn't expect, and this dashboard is able to highlight that. We get great visibility because we're proxying between each container. Here's the graphic of proxying between the containers. Because we are proxying between each service, we can do all kinds of analysis and visibility looking at each of the containers and the way they behave, both inbound and outbound traffic.
Awesome. Okay, I'm sure this question is in some folks' mind. So Rob, this all looks awesome. However, I've got a monolith, or better yet, a distributed monolith on my hands, and I'm not containerized yet. I just have EC2 instances. Can I still use a service mesh, or do I need to evolve into container orchestration before I can leverage this technology?
When you have a monolith, you may not have a whole lot of communication between services. It may just be function calls. And so if you're really not reaching outside the monolith, then maybe a service mesh is too much. If you do have a few pieces to the monolith, you could start pulling in a service mesh. But what it sounds like is at this scale, an API gateway may be sufficient. Just filtering the traffic coming into the monolith may be completely sufficient to be able to get at the security needs that you have. Service meshes can do east-west traffic between virtual machines if you need that. But for the most part, service meshes are focused on communication between containers.
Awesome. Okay, so we've got a few questions from the chat. Thank you. Pablo's asking, can you walk us through why we should use a mesh for untrusted workloads?
Definitely. Why should we use a mesh for untrusted workloads? Well, if service A is some random service and service B is our service, we want to know that only service A is calling service B. We don't want service A calling out to random other things, maybe phoning home with telemetry data that we don't want leaving our cluster. We also don't want service A to be able to accept new requests or remote commands. We want to know that service A is behaving the way that we expect. When we set it inside this so that all outbound traffic will hit its reverse proxy, its sidecar proxy, then that sidecar proxy can go check in with the service mesh. Hey, service A is calling home. Are you sure that that's okay? And so we can say, no, I don't think that's okay. This untrusted workload shouldn't be able to reach out into anything. It should only be able to reach out into those services that we really expect to behave this way. Simultaneously, if our untrusted service is service B, we want to know that only the things that need to are calling it. It's not receiving traffic from outside that isn't expected. So perhaps in this case, this is our ingress controller. And so our ingress controller can check in with the service mesh. Hey, is this request allowed to talk to this untrusted workload? No? Okay, let's not even forward this traffic off to that sidecar proxy. Wrapping untrusted workloads in a service mesh is perfect in ensuring that only the things that we want are executing inside that untrusted workload.
Awesome. Okay, great. Thanks. We've got another question. Chris is asking, how painful is it to switch from a simpler service mesh, such as you outlined Linkerd, to a more complex one like Istio, or the Swiss Army knife versus the kind of basic kitchen knife?
In theory, it's not all that hard. In practice, the finer details do get a little bit hairy. But each service mesh is doing this mechanism of creating these sidecar proxies and checking in with the control plane. So as we're flipping over, we may have some time where both service meshes want to play, or we have a time where neither service mesh is in play. The sidecar proxies will get installed as the container starts up. And so we may want to do kind of a big bang thing where we uninstall the old service mesh, install the new service mesh, tag all the namespaces with the new service mesh's label, and then restart every piece of our cluster. That may get a little bit traumatic. And so we may want to kind of move more slowly where we say, okay, this service mesh is going to control these namespaces, and this other service mesh is going to control those namespaces, and move more gradually, one at a time. Each service mesh will usually have labels on the namespace that indicates that this service mesh should control this namespace. So we could install both service meshes and then slowly move those labels over. Which mechanism works best for you is likely a condition of the tolerance for change in your organization. But I tend to like the Big Bang scenario because it means that there isn't any, well, is this one on the new one or the old one? And how much horsepower are we dedicating to both control planes rather than accomplishing the needs of our business?
Okay, great. We've got one additional question, but we're going to bring that into the breakout session, which is, I already have a Kubernetes cluster, but I don't have a service mesh yet. How can I get started? So if you're interested in talking more about service meshes and kind of some more questions there, come on down to the breakout after.